In the last video of our radicals unit, we're going to talk about complex numbers. Now, you've probably heard when we talk about graphing and domain and range, we always talk about all real numbers. The reason we have all real numbers is because we also have, imaginary numbers. And an imaginary number that we're going to learn today is the number I. And by definition, the number I is the square root of -1. The reason we have this, and you've probably heard throughout other math classes, you can't have a negative in the radicand or under the square root. Well, it's somewhat true. Take the square root of -36, for example. We can simplify this down to 6 times the square root of -1, because the factors of -1 and 36 are broken into two factors of 6 and 6. And so you can simplify this expression into 6 and then the -1 in the radicand, which is left behind. Well, based on the definition of an imaginary number, this is actually written as 6i. And so we can have a negative under the radical, we just have to simplify it a little differently. I also want us to note that when you see I squared, that is the same thing as saying the square root of -1 squared. And whenever you have the square root of, or when you take the square of a square root, these are inverse operations, so they cancel, and you're left with -1. So by definition, I squared is equal to -1. So what does that have to do with complex numbers? Complex numbers are exactly as their name suggests, are complex. The form of a complex number is A plus B times I, where A is the real component of my complex number and BI is the imaginary part of my complex number. And so a complex number has a real and imaginary, and so it's not simple but complex. Bad math pun. So with these complex numbers, we can perform different operations. So, for instance, when we're adding complex numbers, such as 4 plus 5i plus the number 6 plus 2i. When adding these, it's just like adding an algebraic expression with variables. You have to combine like terms. And so, given that it's just a plus sign here, I don't need parentheses. And although I is not a variable, by definition it is a number, we can still combine like terms, or we can still combine the I with, or the imaginary part of the numbers with, and the real part of the numbers. And so I would take 4 and 6, add together to give me 10, and then 5i and 2i to add together to give me 7i. Now when we are subtracting our complex numbers, so the same numbers, 4 plus 5i minus 6 plus 2i, we rewrite our problem. However, since we are subtracting, we have to distribute this subtraction sign to both terms. So we are subtracting 6 and subtracting 2i. And once again, combining what you can think of as like terms, 4 and -6 to a -2, and then a positive 5i and a -2i to a positive 3i, we get the solution to our subtraction problem. The last operation we're going to talk about in this video is multiplying complex numbers. So once again, using the same numbers, 4 plus 5i times 6 plus 2i, we're going to essentially FOIL it. First, outer, inner, last. So we have 4 times 6 to give us 24, 4 times a 2i to give us an 8i, 5i times 6 to give us a 30i, and then 5i times 2i to give me a 10i squared. And then we once again combine the like terms and get 8i plus 30i to give us a 38i. And then notice an I squared. By definition, previously in the video, I squared can be rewritten as -1, which then turns our positive 10 into a -10. And when we combine the real components of our number, we get 14 plus 38i. You can divide complex numbers, but that's going to be for a different video. Thanks for watching.